Hello, and welcome to the next video in my series on operations management. Now, 2 reminders before we get going. Number 1, these videos are geared towards individuals who are relatively new to operations management. So if you have advanced study in this area, these videos are probably a bit below what you would need. Number 2, if you are watching this video on YouTube, please refer to the description below the video, and there you'll find a link to the corresponding blog post for this problem. On the blog post, you will find a download link for the very Excel file I will be using in this video. So you can download that, open it up on your computer, and then follow along with me step by step. So all that being said, let's go ahead and dive right in. Now this video is the first in a series on quality management. Now I will not be going into the very deep philosophical background of quality management. I will be focusing on the small, simple, quantitative techniques that can be implemented immediately in small businesses or in your schoolwork, so you can begin to actually improve your understanding of this topic. Now in this video, we're going to start with what are called check sheets. And we're going to go into Excel, make a check sheet, and then generate several different types of graphs based on that check sheet. And hopefully at the end, not only will you have an idea of how good check sheets are designed, but also how to generate different types of graphs based on that data. And then you can use those graphs in your schoolwork or in presentations in your business or in any other materials you might need to generate. So let's go ahead and dive right in. So here is our problem, and I'm only using this example because this was something I was researching a couple of weeks ago. So you work in the nursing program at a large Midwestern university in the United States. To become state certified, nursing graduates must pass the NCLEX exam, which is offered by the National Council of State Boards of Nursing, the NCSBN. Now each spring, as part of the department's or program's Total Quality Management philosophy, students who did not pass the NCLEX are sent a survey to learn more about why they think their test performance suffered. Now the question is, how can we construct a simple check sheet to record student responses from that survey? So we're going to ask them, what's the main reason you feel why you were not successful on the NCLEX exam, and they're going to give us a response to that question. Now, once we have that data, how can we represent that graphically to inform our understanding, our department's understanding, other students' understanding, and the university's understanding? So, what exactly is a check sheet? Well, at the most basic level, a check sheet is any type of form or document that is used to collect data. Now, I know that's a very general statement, but how they look and work will become more apparent as we go. They are most often used to record the frequency or count of certain events or characteristics. Data recording is done in a manner that allows easy and flexible analysis. So the check sheet is just not a piece of paper with a bunch of numbers thrown on it. It actually has a layout that allows us to record data easily and is flexible when we go to analyze it. Now the layout of the sheet itself is functional. And when we look at some examples here in a few minutes, you will see exactly what I mean by that. The forms are designed so that data patterns can be easily recognized. And again, this goes into how the form is designed. So we should be able to collect the data and just take a look at it and be able to see right off the top certain patterns. Now, check sheets should be reliable across time. So if we want to do a month-to-month comparison, we had better use the exact same or very similar check sheet. Otherwise, instead of comparing apples to apples, we're going to be comparing apples to oranges. Now, along with that, the way the data is actually collected needs to be reliable. So if different individuals are collecting the same data, those individuals need to be properly trained so the data is collected in the same way. Now, check sheets should be valid, so they should be measuring what they claim to measure. So depending on how the sheet is laid out, the data that we're looking to collect, we need to make sure that our questions or the blanks on our check sheet are actually measuring what we claim they are measuring. So here are a few examples. Now in this first example, we have two columns. We have a problem column and a frequency column. And this is actually very similar to the example we're going to do. So we have problem 1 through 10, and then we have tick marks to the right-hand side that are just noting how often that problem comes up. Now in this example, this is a pin diameter check sheet. And this is a very common way of measuring quality in manufacturing. So if you notice, we have lower and upper spec limits, and we are trying to create a pin that has a diameter, I would guess, around 2.1 or 2.2 millimeters. And of course, we take samples off the production line, we measure their diameter, and then we put a tick mark next to the appropriate measurement. And then the upper and lower spec limits are the limits of what we're willing to accept as far as quality goes. Now here is a typing test check sheet. So we have the typist and an examiner, and then we have a list of the type of errors that are made during a typing test, tick marks that keep track of the count, and then of course we have the score over on the right hand side. So this is a check sheet for a typing test. And then finally, this is a check sheet for a door painting machine. This is actually for a robot. So you can see paint robot number, paint batch number, and then the operator, etc. And then the number of doors painted. And this is when I said the form of the check sheet is actually part of the data itself. So on the right hand side, we actually have that picture of a door. So the defect on the left hand side actually has a physical location on the door using those symbols. So a bubble in the paint defect is a circle, a run in the paint is a triangle, and then a scuff in the paint is sort of a rectangle. And the location on the actual door is where those defects took place. And as you can see, that by using the location on the door, you can see that the bubble defects occur in very specific areas. The paint runs most often along the bottom of the door. So when we're talking about developing check sheets, this is a great example of how the actual form of the check sheet contributes to our understanding. So here is our check sheet in Excel. As you can see, it's very simple. We have our explanations down the left-hand side and then our years across the top. So what we're going to do is actually insert our data, and actually I already have the data inserted on our next sheet. Then we're going to do some totaling. So we'll do a total for each explanation and then a total for each year. And then using that chart, we'll go ahead and generate a few graphs that will help us understand our data a bit better in a visual sense. So as I said, I have the data already entered. There we go, that helps us. And for each year, we have the total number of respondents that match each explanation. So for example, under wrong topics studied, in 2009 we had 2 students indicate that that was the primary reason they did not do well on the NCLEX exam. And then we also had 2 more students in 2012 that said the same thing. So this is just explanation, type of explanation in each year. So the first thing we're going to do is do some totaling, and we're going to start in G5. So we'll type total, and in this cell we want the total of ran at a time across all 4 years. So equals sum, open parentheses, we'll highlight those 4 cells, close parentheses, and there we go. So over those 4 years we had 16 students indicate that running out of time was the primary reason they did not do well on the exam. So we're going to go ahead and fill down for each explanation. So I'll just drag down. There we go. And as you can see, the explanation of did not understand the material was the most common explanation. And that should make sense. You know, one of the primary reasons individuals do not do well on any exam is they just do not understand the material that's being tested. So that shouldn't be much of a surprise. Okay, so we're going to go ahead and do a total for each year. So in B14, I will write total again. And this will be a sum for each year. So equals sum, open parentheses, highlight that column. There we go. And I'm just going to drag all the way over and include the total column. Okay, so here's what we know. We know we have 72 total respondents for this survey. Now, does that mean we had 72 people that failed? Not necessarily, because not everyone responds to a survey when you send it to them. So as you can see, in 2009 we had 15 respondents, and 2010 17, 2011 21, and 2012 19. Now it does seem to indicate that those numbers go up a little bit throughout time, but you have to keep in mind that we do not know the size of the overall program. So if the program gets bigger, just by the law of proportion, I guess you would say, there's probably going to be, a proportionate number of students that do not pass. Here is our check sheet, totals for each explanation and totals for each year. Okay, so we're going to go ahead and generate a three-dimensional graph that will help us visualize our data. And in the three-dimensional model, we will actually be able to compare explanations in years more easily. So let's go ahead and select our chart. So we'll start with poor grade explanation, the column heading, and then go all the way down to 72, which is our overall total. So we'll go up to Insert, and then under Chart, we're going to select Column. Then we'll go down to 3D Column and select the 3D column on the far right of that row. So we'll go ahead and select that. And here we are. So here is a 3D graph of our explanations and how they intersect with our years. So this does not look very good, of course. So the easiest way to make a chart look good in Excel, at least in my opinion, is to put it on its own tab. So we're going to go ahead and right-click, select Move Chart, and then where it says New Sheet, just go ahead and click that. I'll leave it at the default because it doesn't matter. Go ahead and click OK. So here's our nice 3D graph of our data, and let's go ahead and figure out how we can interpret this. Now along the back in the lighter blue, that is the total for each explanation, and then our grand total is the really tall blue in there in the back right. Now in the right hand row, or column, depending on how you want to think of it, we have the total for each year. So the dark blue there is the total for 2009, the red, the overall total for 2010, etc. Now if we just take a look at our columns here, we can see that did not understand material tends to have higher numbers throughout, and then our ran out of time seems to be the next highest as it goes across the years, so on and so forth. So this can help us sort of visualize how each explanation and year interact to tell us more about our data. So here is our aggregated data from Excel. So we have our explanations are on the left-hand side, our years along the top, our totals on the right-hand side, and totals along the bottom. And here is our three-dimensional graph based on our previous chart. So we have explanations along the bottom and years along the right, and we can see how each explanation interacts with each year. So let's go ahead and go back into Excel and do some problems involving sorted data. Okay, so here is our chart as we had it. Now, to make it, again, easier to understand, we're going to sort our data as far as the explanation, the number of responses we had. So I'm going to go ahead and select our chart, but I'm going to leave off the total row there at the bottom, okay, because we're not going to want to sort that. We're we're going to want to sort along the total column there on the right hand side. So we'll go to Data, Sort, and we want to sort by total, which is this column right here on the right hand side. Sort on the values, of course, and we want to go descending, so largest to smallest. Okay, so here is our data sorted in the total column there on the right hand side. So did not understand material was the highest number of responses we had, then ran out of time, forgot to study, and so forth. So now we're going to redo our chart in its sorted form. So we will go ahead and select our chart, go up to Insert, under Charts, Column, under 3D Column, we're going to select the one on the far right. And here again is our sort of basic chart. I'm going to move it to its own tab. So we'll go Move Chart to New Sheet. And there we go. So this is our sorted version. So as you can see, this is a whole lot easier to understand because we have did not understand material there on the far left, then ran out of time, and so forth. So our overall totals in each explanation decrease as we go. And then in our years, we can see that those are still in chronological order. So 2009, 2010, 2011, 2012, and so forth. But really the interesting column in this one is the back row and that blue column. So this creates an actual sort of 3D histogram or frequency chart of our explanations in descending order, which is actually going to be very important for our next video. So here is our chart of aggregated annual data sorted. And what I mean by that, if you look on the right hand side under total, we have 26, 16, and 9, etc. So our explanations are sorted in terms of their frequency. And here is our 3D chart of our sorted data. And again, this one is a little bit more helpful because as you can see, the higher frequencies are at the back left. And as we go towards the front right, they decrease. And in more advanced statistics, this is actually a very interesting topic when we're dealing with multiple variables in problems. So we're actually dealing in 3 dimensions here. So again, based on the way they are sorted, you can see that did not understand material is the most frequent response we got, and ran out of time is the second most, and that just depends on what year we're in. So again, we can see in a sorted fashion how the responses interact with the year. So let's go back into Excel and do some more work. So we're going to do one more graph, and again, I'm doing all these graphs so you have different tools in your arsenal. So when you're doing presentations for school or at work, you are able to visualize very simple data in different ways so your audience or your classmates or your coworkers can see it in different ways. You can say, here is my data in this form and here is my data in this form, and it allows your classmates and coworkers and things to see the data differently. So we're going to be doing a stacked bar graph in this example, and to do this we have to select just the data in our chart. So do not select the actual headings for each column, because if you do, very strange things happen. So we're going to go ahead and select our explanations, just the explanations, and then the data values that correspond with each one of them. So do not include any of the total columns or total rows there at the bottom. So once we have the heart of our check sheet selected, we'll go ahead and go up to Insert, Charts, Column, and in this one we're going to do the 3D stacked column, which is the second one over in the 3D column row. So go ahead and click that, and there we go. Now we're going to go ahead and move this to its own tab as well. So we'll right click, move chart to new sheet, click OK. Now we have to do one thing to this, because if you notice on the right hand side it just says Series 1, Series 2, Series 3, and Series 4. That's just one of the oddities of this kind of chart. So we're going to have to go in and change that. So we know that it goes in order. So Series 4 is 2012, Series 3 is 2011, Series 2 is 2010, and Series 1 is 2009. So we'll go ahead and change those. So we will select Series 1, right click, then we'll go down to Select Data. Now what we can do is give each one a name. So in the left hand side of our box here, we'll select Series 1, and then we'll hit Edit, and then we're going to give it a name, which is 2009. And there we go. Just that simple. Go to Series 2, hit Edit, 2010. Series 3, Edit, 2011. And finally Series 4, Edit, 2012. There we go. So we'll go ahead and click OK, and there we go. So what does this chart actually tell us? Well, it shows our explanations in descending order again. But as you can tell, within each bar is the relative proportion of each year that is present in that column. So if you look at did not understand material, we can see that 2009 takes up a significant portion of that column, as does 2011, whereas 2010 and 2012 do not. So if we go to ran out of time, we can see that 2010 has a significant portion, while 2009 didn't hardly at all. So in other data series, maybe not this one, if we see patterns, along the data where a certain year is taking up a significant proportion of each explanation, then we can really go back and take a look at that year and see, what went wrong in our program. Did we not prepare our students well? Was our curriculum off of the NCLEX exam? Were they just disconnected? Are our teaching methods that far off? So we can really go back and look at what was going on in that year. And again, this is just another way of representing our data so that our classmates or co-workers or whatever audience we're presenting to can understand it and visualize it in a new way. So here is our stacked bar chart from Excel. And again, this just helps us, maybe not in this graph, but in other graphs, if we see patterns, color patterns along our histogram, then we'll know that we need to go back and look at those years to see if there was some sort of problem in the testing scenario or in our curriculum or instruction in the department. Okay, so let's review and then we'll be done with this video. So just a reminder, a check sheet is just any type of form that is used to collect data, and as we've seen in our examples, most often it's used to collect the frequency of certain events or to count certain events. Data recording is done in a manner that allows easy and flexible analysis. So if you remember in our Excel spreadsheet, the check sheet we set up was very simple. We just had explanations on the left and years along the top, and because of its simplicity, we were able to do various things as far as graphing and stuff like that. The forms were organized and designed so that data patterns can be easily recognized. So once we sorted our check sheet, it was very apparent what the most common problem was and in what years. They should be reliable across time, and they should be valid, which means they should be measuring exactly what they claim to measure. Okay, well that wraps up this video. Again, we'll be doing more quality management videos in the future, in the near future actually, so make sure to check back. Again, thank you for watching, and I look forward to seeing you again next time.